Okay, so welcome back to another video. Today's going to be a quick video, so what we have is an improper integral from 0 to infinity of 1 divided by x to the power 5 plus x to the power 4 plus x to the 3 plus x squared plus x plus 1 dx. So this is actually more of just a quick exercise on how to utilize the U-substitution, since this is actually the way on how to focus on tackling this problem. And it actually is a little straightforward from there, that what you'll notice is that if we actually do a U-substitution, we're actually going to get an integral such that it's actually an exact copy of this one, where the strategy is that we're actually going to take double of what our given integral is that was originally what we set that is equal to, utilize that, and then create another different integral such that it will be a little bit easier to work with that. So other than that, let's actually just jump right in. Now, as I mentioned, what we're doing is we'll be using a U-sub. So now suppose that we let U equals 1 divided by x. Now, if I have to let x be by itself to do that substitution from over here, so that means we'll have that x is equal to 1 divided by u. And if I differentiate both sides, I have that dx is equal to negative 1 divided by u squared and then du. So that's nice that we have a dx differential to substitute by itself. Then we substitute everything back in. We have to change our bounds too. So I have x is equal to 0. So that means u would have to be positive infinity, approach positive infinity. And if I have infinity, that means u would have to approach 0. And if I substitute everything under the denominator for x equals 1 over u, so now I'll have 1 divided by u to the power 5 plus 1 divided by u to the power 4 plus 1 divided by u to the power 3 plus 1 divided by u squared plus 1 divided by u, and then add this with 1. And we would have that under the denominator is that this is, with the differential substitution, I have 1 and then u squared du. Over here, this will be negative 1 with the negative over here. And then what is great is that I have to change the bounds of integration. So that means, because we have 0 for upper bound, infinity on the lower bound, that means fixing this, I have infinity, then 0. And then what's great is that the negative will cancel out, and I'll distribute the u squared into everything under the denominator. So now what we'll have is now just 1 divided by u to the power 3. Add this with 1 divided by u squared plus 1 divided by u plus 1 plus u, and then plus u squared. And then this is going to be on the top, is going to be 1 and then du. And now what I'll do is, to make simplifying things a little bit easier, let's multiply a u to the power 3 to both the numerator and denominator, just so we don't have any fractions we're dealing with on the denominator like that. So if I do all that, that means I have a u to the power 3 on the numerator, and then putting all this back together. So you'll notice that it's actually kind of the same thing as like with the denominator for what was our given with the degrees, and I'll just rearrange that so the leading degrees comes first. So that means I have u to the power 5 plus u to the power 4 plus u to the power 3 plus u to the power squared plus u, and then plus 1 and then d. So what you'll notice is that it's just in reverse, and then just using, commutativity with addition, so that'll still work. And what you'll notice is that these two are equal to each other, so I'll call this I, and so this is the same thing as I as well. So now with that in hand, we'll actually double the amount of I, so 2I, and what I'm going to do is I'm actually going to take these two and add them together. And what's great is that now going further, this is 0 to infinity of now u cubed, well rather, we're back into that, I'll just go back to the world of x, and then it doesn't apply, this is just a dummy variable of x cubed plus 1, and then divided by x to the power 5 plus x4 plus x3 plus x2 plus x, and then plus 1, and then dx. Okay, and so from here is that what we need to do is we'll actually have to factor this out. So this is actually a good exercise that if you want to verify yourself, that what we have on the bottom is that we can factor that out of x cubed plus 1 and then multiply with x squared plus x plus 1. And then we still have x cubed plus 1 on the numerator, and that's great that it's going to cancel both of these out. So now what we're left with is 0 to infinity of 1 divided by x squared plus x, and then plus 1 dx. So how do we take things further from here? Let's actually complete the square for the denominator over there. So now doing so infinity, then 0. So now if I actually just complete the square from the bottom, that means I'm going to have now x and then plus 1/2, then quantity square, and then add this with 3 over 4, then dx. And you notice that if we actually now do another u substitution, we'll let u equals x plus 1/2, then du is going to equal to just dx. So now we have a new integral. So plugging with our new bounds, this is still going to be infinity. Meanwhile, on the bottom, we're going to have positive 1/2. And so this will be 1 divided by u squared, and then add this with 3 over 4. Notice that this is actually in a nice form of an arctangent antiderivative. So we notice that 3 over 4 is in a form of a squared, that we have to solve for a on its own, because the unique antiderivative for that arctangent written as 1 over a multiplied with arctangent of u divided by a and then plus c, but we have our bounds, so that's okay. So by doing so, that means we'll now have this is 2 divided by the square root of 3 multiplied by the arctan of 2 times u, and then divided by the square root of 3, and then evaluate this from 0, or rather 1/2, to positive infinity. And so if I plug infinity, so that means, so let me first write 2 square root of 3, and then if I plug in infinity, that's going to be pi divided by 2. And if I were to plug in, I actually wrote 0 again, sorry about that. So that's supposed to be a 1/2. And then if I plug 1/2, so I have arctan of 1 divided by square root of 3. That's the same thing as pi divided by 6. Okay, and so what I'll do is that, again, this is set that this is 2 times I is equal to this value. So I'll say 2I, and then continuing further, that I is equal to 2, or rather 1 divided by the square root of 3, and then pi squared, or pi divided by 2, and then minus pi over 6. Simplify that out, that will get that this is just pi divided by 3 times the square root of 3, and that is indeed our final answer for the simple, well, rather fast improper integral that we wanted to solve from the beginning, just like that. So yeah, that's pretty cool if you ask me.